Hi, this video is to introduce Lab 3, which is displacement, velocity, and acceleration. Okay, today we will use that software which is called BeyondLabZ, and we will be able to study displacement, acceleration, average velocity, instantaneous velocity, and many things that we are going to actually understand today from doing this lab. Let me move to the student view so that I'm sure that you are able to view what I have in here. This is the link where it's going to take you to the lab, and this is the document that contains the instructions. Okay, let me go over it first. Here we are going to calculate the velocity of an object from measuring of displacement and time. We will compare the instantaneous and the average speeds and know like what is really the basic difference between them. We're going to graph displacement versus time for objects moving with constant velocity, and we will do that also for objects that moving with constant acceleration. We'll graph velocity versus time for objects moving with constant acceleration, and finally we will be able to calculate the acceleration from a velocity versus time graph. Of course, this has to do a lot with our life, everyday life. It is talking about all types of motion that we have in our daily life. Of course, here we are going to introduce today velocities like speed, velocity, displacement, acceleration. And for today's lab, it's going to be a formal lab report. Formal lab report means that is going to be a lab that we are going to have like a cover page, abstract, procedure, equipment, data, calculation, sample calculation. Also, we are going to list our results, list our graphs, make a conclusion. And if there are any questions, you can answer them. In today's lab, we have these pre-lab questions that I want you to answer these before you start with the lab. And then finally, this is the procedure. We are going to have like two sections here. One of them we will study constant velocity motion, and the second one we are going to study constant acceleration motion. Okay, and now let me start by introducing the lab here, and just 1 second. Okay, I think because BeyondLabZ is a little bit different, I will not be to work and show you the, and read for you from the instructions on Canvas. This is the reason why I want to have my instructions printed so that I will go over the lab with you. Now, the first thing that we are going to do is the first one is I'm gonna close this one because I want to go to the lab, which is this one here. Okay, I'm gonna go to the portal. Okay, it should open to you, or just if that link did not work, I don't know why it did not work. Just you are going to go to your BeyondLabZ. We will not use the web here. Look, this is the web, this is the desktop. Then you are going to hit the desktop. Okay, and I will open the virtual physics lab. There are here different like worksheets and like experiments. I want to go to this one, measuring speed. And this one will open in what is called the mechanics lab. My object here, it is this box. Can you see that orange box to the right corner here? This is my object. Now then, according to the instructions, we said start virtual physics and select measuring speed from the list of assignments. The lab will open in the mechanics lab. The lab will be set up with a block, and now we are going to assume that this table is frictionless. And attached to it, there is a plunger that is gonna use to hit the block and then cause it to move. Now, one thing that I want you to know, that force is not gonna stay with the object. This force is just for firing the object. Then after leaving, okay, after leaving that, like what causes the force, we will not have any force acting on it as a driving force. Of course, we're going to have the normal force and we are going to have the weight. We don't have friction and we don't have any forward force. Okay, and the object here, because there are no forces along the x-axis, assumingly is going to move with constant speed because the table is frictionless. We will measure the length of the table and the time, and you can see this is gonna show the distance that the object has been moving. This one is gonna measure the time. Okay, then we are going to record these values, but just also we need to record the whole motion. And the first thing that you need to know also, that the plunger is initially set to hit the block with a force of 78. Then you can say here that the force that you are using, it is 78 in newtons. Now start the block sliding by clicking the force button. When the block gets to the end of the experiment, it will stop. Observe the final position. I will say, before doing that, I will say, I want to record that first. Then you should hit the recording first. Now it is recording, and then I'm gonna hit the force, and then the force is gonna act on the object, and the object is gonna move along. And now the force was 78, the distance is 500 centimeters, and the time is 1.3. And this should be in the table under 13, which is should be listed under results section in your lab report. This is one section of, I will say, the results. There is a table that is going to ask you about the force, the distance, and the time. Okay, now we are going to redo the experiment. We are going to reset and use two different forces. One of them is more than 78 and the other one is less than 78, and we're going to do the same exact thing. Then I will say now here, I can reset. I can go here to parameters. I can go here to forces, and then I can make that force, let's say 50. All right, then my force now is 50 newtons. I will hit recording, and then I will hit force. And again, The force now is 50, and the distance 500 centimeters, and the time is 2.02. All right. I will do this experiment one more time. Then I will reset again. I will go to parameters. Now my force, I want to have it, let's say 100. And I will record as well, and then I'm gonna hit the force. Okay, in each of these 3 attempts, you are going to record the time, the force, and the distance covered, the distance of slide, and these are going to be listed in the table that is going to be in the second page, and that is going to be under results. Now it's the time for graphing. Then I'm gonna go here for the lab book here, and you're gonna see I have here 3 data sets. The first one, it is for the 78. The second one, it is for the 50 newtons, and the last one is for the 100 newtons. Now what you are going to do is you are going to click on that. You're going to copy, and then you're going to go to Excel, and then you will, okay, let me close that first. Okay, then here, oh, still have a new black one here, blank, and then here I'm gonna paste, and I will have these make them bold, have them centered, and here you're gonna say force equal 78 newtons, and then I'm asking you to plot the data into paste the data into an Excel sheet and plot a graph of position versus time. And that is as easy as this. You are going to highlight, and then you are going to say insert, and is gonna scatter plot. And just I want you to be sure that your time is along the X and your Y is the position. I need also to move my chart to a new, here I will say F equals 78 newtons graph, and then okay, and then I will quick layout, and then I will do here position centimeters, and here time, and here I should give it a title. I will say position versus time. Now I need to also bring the other data that I have, which is the other 2 sets. Okay, then here we did copy the first one. We did not copy the second yet. Okay, for the second one, I'm gonna say copy. I will go to my Excel file. I will go to the data here. Okay, let me say here data. Okay, and I want to have them all in the same. Okay, then here I have, this is my second data here. I should have a title saying force equal 78, and then you are going to do 78 newtons. You're going to merge all these cells together. And center and make it okay, and I will say also make this 14, so that is gonna be clearer. Okay, I'm gonna do the same here. Okay, this one, it should be aligned again here. All right, and I'm gonna do here, I will say the force equals it. This was the 50 in newtons, and also I'm gonna have it 14. I'm gonna have all these merge and center and have that bold as well. Now I will go to my graph and I will click on select data, and here I will say the name for that was force. Okay, force equal 78 in newtons. I will add another graph. I'm gonna call it force equal $50 in newtons. For my x values, I'm gonna say equal, and I will have for x my time, and for my y I will have my r, and then I'm gonna hit OK. Now I have the second graph. I will also go again to the data here section, copy the data again, go to my Excel again, go to the data section, and then paste the third one. I'm gonna say here force equal 100 in newtons, make that 14, merge and center for the title and have it bold, and then I'm gonna go to the graph again, select data here, and then I will say again add, and that F equals 100 in newtons. Again, I will go to the data again and I will select the time here for these values, and then I will select R, the position, and then say OK. And then now I have all my three graphs I like to have the graphs after moving the sheet. Okay, and then now here I have 3 graphs. I will right click and first select the points. And then add trend line, linear, and have display the equation. You are going to do the same for, I want to move it because this is for the one in the middle here. When we format the trend line, as I said, you are going to take the linear and you are going to say you have the display the equation on chart. Okay, now you're going to do the same for the other graphs and find the slope. Now actually what's gonna happen here is that since this is position versus time, then I can find from these slopes the speed of the object, and I will calculate these for all the 3 using the equation of the object. Okay, this was procedure number 1 or section 1. I'm gonna repeat the experiment now. I will go again to the experiment and I will close this here. I'm gonna reset my experiment again, and then I drag the sliding friction icon from the tray at the top down onto the table. This will turn on the table friction to a value as if the table and object were made of plastic. Now this will not go down like I tried. It's gonna go here. That's it. That's okay. And now if we go to the friction, look here, it's gonna say the object is plastic and the surface is plastic. Then we have kind of friction. Now we did not ignore friction. Again, I will click on the recording button to save the experimental data, and I will repeat and record the distance traveled, the time it took, and your calculation of the average speed below. Okay, then here, okay, I'm gonna click on the force, and then now here what I will have is I will have that data again. Okay, sorry, this is number 3. Now I want to copy number 4, copy data, and then I'm gonna go to my Excel. I'm gonna go to a new sheet, and now I will say this is going to be my new sheet. Now if you check if you check your forces here, my force is 100. Can you see it? Then it's 100. I can go again to my Excel, then I will say force equal 100 in newtons, and I will say with friction. Okay, and again that title is gonna be 14, is gonna be bold, and then I will make that center and merge. Now here what is required, I'm required to graph 2 positions, 2 graphs. One of them is gonna be T versus R, and I will say insert again I will say this is what is gonna be. You know what, I advise you maybe to change the force into 78 because it's gonna show you a clearer behavior. But like 100 is not gonna be a problem, but let me show you the difference, what I mean. Okay, like if I go back here and change my force into 78, okay, and or 50, whatever, it's okay. And I will record, and then I'm gonna have the force. Oh, I did not reset. Okay, then 78, and then record, and then force. What's wrong? Why it's not moving? It's not gonna move. This is very strange. Let me bring this here. Recording. Yeah, because this is very sensitive to, yeah, okay, then now here, this is my new data table here, is gonna be the last one. And if I will copy that, let me show you the difference. It's gonna give me this graph, which I prefer because it's gonna show you the shape of the graph is gonna be clearer because is gonna be more points. Then look at the graph here, showing you the position versus time for this object. Again, I'm gonna repeat the same thing here. You're gonna transfer this graph to the new page, to new sheet, fit it, put the equation on it, and the last step is going to be, we are going to have velocity versus time. Then I will say, I'm gonna graph, I'm gonna say T, insert another graph here. That is, but what I want here is, I'm gonna select the data. I'm gonna say velocity versus time. And for the X values, I'm gonna have the time, that's correct. And for the Y, I want to have the velocity. And then okay, and this is my graph. I'm gonna also move this graph to a new sheet and verify all the rubric, like a title and everything related to graphs. And we are going to use that graph to calculate the acceleration. This is step number 9. Finally, we are going to calculate the average speed of the block using the data from table number 2. Okay, table number 2 is going to be your, very similar to table number 1, where you're going to put the force, the distance of slide, and the time of slide for your object when there is friction. And there are, of course, questions that you are going to answer as well. I hope this is going to be beneficial for you to do the lab. If you have any questions, don't hesitate to contact me. Thank you.